All right, today we're going to be working with polynomial functions. Polynomial functions. And before we get into polynomial functions, e-learners, there will be no Zoom meeting on April 14, 15, or 16. No Zoom meeting on April 14, 15, 16. That's Wednesday, Thursday, Friday this week. Assignment. Assignments will be posted to Focus. All right, regular day today, regular day tomorrow. Then Wednesday, Thursday, Friday, your assignments will be on Focus by date. And then you will have a homework assignment / move your answers over that corresponds to each assignment each day. Understand? Same for you guys in class. It won't be counted as a quiz. It'll be counted as an assignment. You'll have a sub on Wednesday, Thursday, Friday. You'll have a handout, a worksheet to do. After you finish your worksheet, you're going to treat it like a quiz. Okay? You're going to go to under the alerts tab and move your answers over. It'll be review type stuff. It'll be fairly simple, but it will be math. Got it? All right. It's gonna work, function like a quiz, but it's not gonna be as a quiz grade. It's gonna count as a homework grade. Does that make any sense? It's gonna go against you, but it's not gonna hurt you. It's review stuff. So if you have a calculator and you know how to use it, and you paid attention at all over the last 9 or 10 years of your life in math, you should get at least 90% of the problems correct. And if you actually try when you don't, okay? So there'll probably be like 12 to 20 questions for you to do on a worksheet. When you're done, move your answers over. They're either going to be true, false, or multiple choice. All right? And you should get a bunch of them right. Got it? All right, first part of your assignment today, you're going to be writing your polynomials in standard form. And you're going to be classifying them. So we're going to draw this table, and this table will help you do all of that. All right? So we're going to start off with the degree of the polynomial. And then we've got the name. And then we're going to do an example. Number of terms and the name using terms. We're going to change this over here to name using degree. All right, so we've got what we got here. 1, 2, 3, 4, 5 columns. All right, so a polynomial that has a degree of 0, its name using its degree is called a constant. You know it as a regular number. It has one term, and it's called a monomial. Polynomial with a degree of 1 is linear. An example would be something like x plus 4. The number of terms would be 2, and it's called a binomial. Now, where this degree is coming from is the exponent of the variable. This variable right here is x to the first power. But when x is raised to the first power, we don't write that 1. It's implied. Just like we don't write the 1 in front of the x. It's implied. All right? So this 1 degree, or this degree of 1, is the power of the leading term. So if we got a polynomial with a degree of 2, then it is quadratic. All right? An example would be 4x squared plus 3. This number of terms comes from the number of terms in the polynomial. All right, again, we've got 2 terms here. We got 4x squared is 1 term, and we got 3, it's another term. So we got 3 terms. I'm sorry, we got 2 terms. And it's a binomial again. Degree of 3, the polynomial is cubic. That means when it's written in standard form, we would have something like 2x to the third plus 3x squared plus 1. This polynomial has 1, 2, 3 terms. 3 terms is a trinomial. Let's go to a degree of 4. Quartic. Quartic is the name by degree. An example, 3x to the fourth plus 2x to the third plus x squared plus 1. Now we've got 1, 2, 3, we got 4 terms. Once it goes over tri, it becomes a polynomial of 4 terms. Polynomial of 4 terms. If there was 5 terms, it would be a polynomial of 5 terms. All right, so let's go to degree 5. The name of the polynomial using its degree would be quintic. We could have negative x to the 5th plus 4x to the 4th minus 3x to the 3rd plus 2x squared minus x plus 7. And that's got 1, 2, 3, 4, 5, 6 terms. And that would be a polynomial of 6 terms using the number of terms as the name. Good with that? So next thing we're going to do is we're going to write some polynomials in standard form. So we're going to write in standard form. And name, did I use the word name? Classify. We're going to classify. Write in standard form and classify by degree and number of terms. So when we're writing them in standard form here, and we get 3x plus 9x squared minus 2. When we're going to write these in standard form, when it's in standard form, your exponents are going to be decreasing from left to right. Okay? So what you do is you reorder the terms with your highest exponent on the left. So we take this and we rewrite it as 9x squared. The next highest exponent goes to the right of that, which is the 3x to the first, so plus 3x, and then the minus 2. Now, we're going to classify it. So when the degree is 2, it's a quadratic. And it has 1, 2, 3 terms, so it's a quadratic trinomial. For x minus 6x squared plus x to the 4th plus 10x squared minus 12. Same directions. We're going to reorder this thing, and we got to combine like terms as well. So we got our x to the 4th goes first. And then we got a negative 6x squared, and we got a 10x squared. So we got to combine those. At negative 6 plus 10, that's a positive 4x squared. Then we got a positive 4x. And then we got the negative 12. By degree, our highest degree is the 4, so that is quartic. This is a quartic polynomial. of 4 terms. There's your 1, 2, 3, 4 terms. Get the idea? Let's do one more. Let's do 3 minus 4x to the 5th. Plus 2x squared plus 10. All right, this power of 5 is the highest, so it goes first. We got negative 4x to the 5th. We got a positive 2x squared. We got to combine this 3 and positive 10. We get a positive 13. Our highest power of 5, so this is quintic. 3 terms, trinomial. Quintic trinomial. All right, in the second part of your assignment today, you're going to be determining, let's see here, second part of the assignment, you're going to be asked to determine the end behavior of each polynomial function. We're going to do another table right here. We're going to say A positive and A negative. Then we're going to go N even and N odd. A is the number in front of term 1. All right, so this A in this table is the number in front of term 1. N is the power. Let's say degree. So while we're on this page right here, and I can still see this last polynomial, this A, or the A for this polynomial, would have been the negative 4. N for this polynomial right here would have been 5. Going back to the previous, a for this polynomial would have been 1. The number in front of the first term, there's a 1 there, it's just not written. The n would have been 4. That's the power of the first term. Above it, one more, we got an a that would have been equal to 9, and an n that would have been the 2. Those two numbers tell you tons about the graphs of these polynomials. The graphs of these polynomials are parabolas and lines that move and curve, okay? So when we're talking about end behavior, when our a is positive and our n is even, the end behavior of this graph is up and up. We got up and up. Look, an up and up graph, it could look like this. It could be a parabola. It could go here, 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 here. And you can continue that process. All right, this first up and up graph, this parabola, has one turning point. It goes down, comes to the vertex, turns, goes back up. This next up and up graph has 1, 2, 3 turning points. All right, you can go to graphs with 5 turning points, 7 turning points. If they're finishing up and up, they're always going to have an odd number of turning points. So when you're looking at a polynomial and you're asked to determine its end behavior, if the a is positive and the n is even, the end behavior is up and up. If the a is positive and the n is odd, your end behavior is down and up. Down and up. An example of a graph that's down and up. Right here. Down and up with more turns. Could be here, here. 2 turning points. When you're looking at a polynomial and it has an a that is negative and an n that is even, that's down and down. Down and down. Down and down graphs. Here we go. Then we can go here. We can have a turning point, another turning point, another turning point, and back down. Here's 3 turning points again. But your end behavior is down and down. And there's only one combo left, isn't there? When a is negative and the n is odd, the end behavior is up and down. Up and down. Up and down end behavior. Right here, here. Here. All right, so let's do a couple of these as well. Let's consider the leading term of the function. What is the end behavior? Y equals 4x to the third minus 3x. End behavior. Our a here, our a is 4. And it doesn't even matter about that as much as the positive or negative, right? So our a is positive. Our n is odd. A positive, n is odd. That's down and up. There's your end behavior, down and up. If we get all of this, y is equal to negative 2x to the fourth plus 8x to the third minus 8x squared plus 2. Our a is negative. Our n is even. Negative and even. Negative and even. That's down and down. Down and down. When you are determining this end behavior, be sure that your function is in standard form. Be sure your function is in descending order of your powers. Okay? Or just be sure you're evaluating the data from the highest powered term in the polynomial. So, your assignment for today, page 285. (8) through 31. That's going in the basket. Or you're going to email a pic. For those of you that came in late, no Zoom. Wednesday, Thursday, or Friday this week. No Zoom on Wednesday, Thursday, or Friday this week. I'm going on vacation. Yes, buddy. I can't tell you yet. I'm going to wait till I stop this video. All right, you e-learners, you're excused. Go get your assignment finished and get it sent to me.